Hi everyone. Welcome to the webinar. And today I'm going to introduce ParaView, one of the most popular visualization software. And today I'm going to use the course material that I used to teach at the summer school last year. And because the visualization course at summer school runs 3 hours, but today we only have 1 hour, so I cut some of the contents out. And if we have time in the end, probably we will touch some of the advanced topic. And also I'm going to take a different approach to present the seminar today, and I'm going to focus more on the use of ParaView by real example instead of introducing the fundamental part of the structure and etc. So let's start. So first off, we are going to give a very quick introduction, and then the main part is we are going to show you how to use ParaView and in the end, I try to leave like 5 to 10 minutes for questions. Okay. So what's visualization? Visualization is a technique that transforms data into graphical form so that we can see. So here you can see a lot of graphics. Actually, if you look behind it, there are numbers. Okay. And why we need visualization? Someone might say, I need a picture, to insert into my paper, and some others may want to have a attractive animation and to show the audience at a conference. Okay, those are good reasons, but more importantly, I would like to use visualization tools such as ParaView as a powerful tool to explore or discover the contents of the data, or to find hidden patterns or structures inside the data. So that's more important than just generating pretty pictures. And old saying is, a picture is worth 1,000 words. But I would replace words with numbers. Okay. Here is an example. I just show the daily S&P 500 index data within a month. If I just show the data like a column in a table, it's really hard for you to to understand the movement of the index. But if I show it as a graph, here is a candle graph. If you have experience with the stock trading, you can see it's very easy to understand. You can just know how many peaks or valleys are there and how the whole trend moves. Also, a lot of pictures, 2D pictures, they actually are 2D array of numbers. So here, if you zoom in the CT images, zooming at one spot, you actually find that there are actually numbers behind them, just 2D array of numbers. And for color images, they actually have three array of numbers, are red, blue, and green, respectively. And there are more examples. So although they look quite differently, behind those visualizations, there are numbers. Okay. So now let's take a quick look at ParaView. ParaView is very popular, and it's open source. And the latest version is I checked yesterday, is 5.2. And you can run ParaView as standalone application, or you can run it as parallel for if you have a large data to visualize. It can run on multiple platforms, and it supports visualization of different type of data and in multi-dimensional space. And if you need help, there's numbers of ways to get information like guide, wiki page, tutorial, and webinars. They are provided by Kidware, the company behind the software. And also, I find it very useful if you have question, you can submit your, you can send your question to the mailing list. Someone will answer your question quite instantly. And also, you can use online help, which comes as a bundle with the executable. It's very convenient as well. Okay. So before we start using Explore ParaView, I'm going to introduce two important concepts. One is pipeline. So what is pipeline? So the philosophy of ParaView is like this. You load in your data by some reader. By the reader, it's called a source. So you load your data into ParaView, and you can afterwards you can show your data in different ways. But if you are not happy with the way that you can visualize, you can transform the data that you have just loaded in and to another form of data by using filter, and then visualize it. And you can also have another filters or operation applied to the data, so you can just connect them together to form a pipeline to achieve the goal of visualization. Okay. So here, each component in the pipeline, they are either a source or a filter. Source doesn't have input; it only generates output. And the filter, on the other hand, it takes a data as input and it generates another data set as output. Of course, you can control how the filter or the source performs by using parameters. Okay, so quite similar to the IC chips. So it takes some signals in, generates some output, and there are some pins to control how to operate. And there's a question then, when you try to connect filter 1 with filter 2, is the data compatible? In ParaView, you don't need to worry about this. The reason is that ParaView takes care of it. So once you select a data or a filter, and you want to connect to another filter, you search through those candidate filters, you will see that only those filters that are compatible with the data are shown. Those are not compatible with the current data are grayed out. So you won't be able to make a mistake. Okay, another concept is data. Here the data is something like sampled data. So imagine that like we live in a 3D continuous space, but we want to study. Let's suppose we want to study the temperature variations throughout a room. Imagine we have a 3D array of sensors that can sense the temperature. So we have a 3D grid that's spread through the within the room, and each grid point we snap a sensor there, so we can pretty much sense the room temperature distribution by using a 3D array of grid. The denser the grid is, the more accurate you can get, and so that's it. And in this case, if the grid is uniformly aligned, so we call it a uniform rectilinear grid. But you can determine the topology and the structure of the sample points in another way. For example, it's a lineup along X, Y, and Z, but at a different spacing. That's called a non-uniformed. Or it's curved. We call it curvilinear. And we have multiple ways to, either unstructured grid. It depends, but in the simplest way is use uniform rectilinear grids. Okay. Secondly, instead of using temperature sensor, we can use some other sensor to sense, for example, to sensor speed. Airflow. If we are interested in studying the airflow within a room, we can, you can just imagine. But the data are not only coming from measuring the real world, but it can also come from numerical simulation. And so later on, probably you will find a lot of simulation that's running on Sharcnet that generate a lot of different types of data. All right. So at each data point, as we mentioned, it could be scalar, like temperature or pressure or densities, and it can also be vector, like velocity. Okay. There's others like tensor or coordinates, etc. But the scalars and vectors are two most frequently studied properties. Okay. And at Sharcnet, we have visualization stations. They are very powerful, but of course you can run ParaView on your desktop. But here I'm going to demo how to take advantage of Sharcnet visualization station and to use it there. And I'm going to use the VNC. Okay, connect. So here I'm going to my summer. Okay, this is where, okay. So basically, now I'm on the view station Fedora 20. And the way I start ParaView is you type ParaView and hit return key. But to let it run in the background, I use this sign. Okay, so first let us get familiarized with the GUI. you can see the first, this is the menu bar, followed by toolbars, and this part is called the pipeline browser, and it show you the pipelines you have built so far. And the bottom part on the left is you have two tabs. One is called property, show the property of the current data that highlighted in the pipeline browser, and the second show the information. And the left part is called a render window, and I'm going to turn off the animation in the bottom. Okay, so pretty much that's the GUI. So first, let's load in our data. So I'm going to load our tutorial data that's used by most people. So I load this data, and here you can see that it's not loaded yet. So it's actually asking me, what do you want to load? You can see in this data set, it contains the multiple attributes. It has temperature, I check that, velocity, pressure. I don't know the rest, probably some concentration of those like hydrogen or whatever, I don't know. But if you are majoring in chemistry, you may know it better. So after that, I choose some. If I don't choose some, I uncheck that one. I apply. So here I see my display here. Okay. But you see, okay, it's not much. But in the web, the pipeline browser, you can see there's only one element there. It's called a disk. It's actually the file name. It's the reader reads this file. Okay. And so far, you can scroll down, and the first part is property. It's almost done. I just collapse it. And then the display, so use surface, but you can use other way like outline. You can use points. There's a lot of points there. You can use like surface with edge, but I pretty much prefer use surface for this one. But then you will see what's the meaning of those. You said you load in multiple scalars like temperature, pressure, etc., plus one vector called velocity v. But here, what it is? What's this one? Okay, it's because here I show nothing. I'm going to show, let's say, pressure. Okay, I choose pressure. Now I see. Oh, okay. It's color coded. So here's my color map. So the red means the hottest, the highest pressure, and the blue shows the lowest pressure. Okay, you can see the pressure get the higher here and the lower there. Okay, so that's the distribution, but you don't see inside. What's the inside? Certainly, you can choose some filters, like I click a filter like slice. I slice through, okay? I apply. So here's my slice, okay? I can see that now you see the pipeline from the disk. I have another one called slice. Slice through, and now I'm going to choose this one. You see, I can change the slice position. I can take it to different location, apply again. I can reorientate the plane like this and click apply. I can see different layers or different slices, but it just show me something at one time. But it's hard for me to get the overview of the data set. Okay, So this is not nice. So I'm going to turn it off. You see the little eye here on the left in the pipeline browser. I just turn it off. And I turn back to the original one. But instead of a surface, I think I want to display it in another way. I scroll down and I'm doing, instead of surface, I choose volume. Volume rendering is a technique that you actually assign the value, map the value to opacity and color. So here is the map on the right. So so now I'm showing the pressure. Okay. So the pressure is the lowest I map to color blue. The highest pressure I map color red. But you see the slope? The slopes actually show the opacity, which means the lower it is, the more transparent it will be. But I can actually change it and make the lower part even more transparent. Make the high pressure portion more opaque, so you can see different part, and you can bring it down. Even for the highest part, you can bring down. Now you can see something inside. Okay, you can see the distribution there, and also you can change the property. Instead of pressure, now you say, oh, I'm interested in some other things, like say temperature. Okay, you see temperature is different distribution. You can use some others. I don't know what is ASH3, but it's just some scalar there, scalar property. So here I'm showing you how to display different properties or attributes. So, but you argue that although you have multiple arguments, some of them are scalar, some of them are vector, but you don't have a way to show them all in. If you are interested to see them all, how could I do that? So our simplest way is use multiple view. See this part? You can split the render window into multiple, split it into half. Okay. Now for this one, I'm going to show the same object, but instead of I'm going to hide this part. I just focus on display. So if I collect everything, you see just the three. Although you see a lot of, so actually three main part: property, display, and view. Okay, so you can collapse and extend. Okay, so here for this one, I'm going to show, for example, I use surface, but this time instead of solid color, I'm going to show what's that? Temperature. Okay. I show temperature here, and you see, the temperature is, it's hot inside, but but once you show this, but they don't behavior the same way. But how about if you can link the camera together, then you can make. So right click on one of them, click link camera, and click on the other one you want to link. Now they are, once you rotate one, the other one rotate accordingly. By the way, I just want to quickly explain that. The left mouse button is for rotation. The right button is for zooming in, zoom out. The middle button is for shifting. But if you have a mouse with a wheel, actually the middle button is I think my mouse is stuck somehow. Okay. So the middle, the wheel can zoom in, zoom out as well. Okay. And now you see there's another way for this one that I can, for example, I can cut it into half, so that I can view it in this way, or this is you can even split further. For example, this one I'm going to show another property of, for example, hydrogen. So what I'm going to do is display. Where's display? Okay, present display. Okay. Oh no. Okay. So I'm going to choose a volume rendering for this one. But this time I'm going to visualize temperature. Oh, not temperature. Temperature here, pressure, for example. Okay. So you can also link them together. Now you have a different way of viewing them. Okay. So this is cool. But how about the visualization of the vector field? So suppose here we are interested in, I just delete those two because I'm not interested in clipping or. So how about we visualize the velocity? So you click velocity. Okay, here we are. We have something here, but it's not exactly what we want, because here we visualize a vector by its magnitude. It's in other words, somehow it's actually we transform the vector into scalar. The scalar is the magnitude of the vector. That covers some information of the vector for sure. It tells me where the highest velocity is, but it doesn't give me the information where the vector points to. So okay, so let's do it right now. One way is we can, instead of we can first we need to extract the streamline, or by clicking a stream tracker, by apply. So now what we have here is, I turn off that one. We have a streamline that represents the trajectory of those velocity field. Okay, you can zoom in, zoom out. You can use the arrow to show the information. So click on the representation, change the representation from surface to 3D glyph. Okay, but okay, this one doesn't make the no, not this one. So it's still surface, not this one. You can apply another one. I mean the velocity. Let me see the XYZ coloring. Display velocity. You apply the glyph to either the original one or this one. I apply a glyph to this one. So basically, you click glyph, And you can choose the property here. If you like a arrow, you choose arrow, which is the default. You apply it. So you can see now the arrow actually points to where the vector is. These are kind of messy, but this is the orientation it is to make it a little bit better. And you can say, okay, I want the velocity not to the norm, but to the speed. Apply again. This makes much sense now. Okay, so make sure you choose the right one. So basically, I make the vector point to the v direction, which is the velocity that we loaded in, and you can scale it. So you can scale it to scalar, and let's choose a scalar. Let's say I choose h2 and apply. Now you can see that the arrow is different sizes, and the size actually represent the another property called H2. I think it's a hydrogen concentration or density or something. So you can see it's pretty much showing the 3D the airflow in 3D. Okay, and now we can make it nicer. Instead of glyph, I just focus on those streamlines. I want to make it like a tube. So basically, you select the source, which is streamer tracer, is the line, and then I will surround. So I click a filter. So those are filters here in the toolbar. That lists most commonly used filters. But you can certainly choose filter, and the filters are actually organized in categories as an annotation and a data analysis filter, or statistical one, or the overall in the alphabet order. And here I choose tube, and I just click OK. So I got a tube. Okay. But this tube looks not very nice to me. I'm going to make it looks a little nicer. First of all, I'm going to make the tube thickness variable to some of the attributes. So I choose CH4, and here I say vary by scalar. Apply. It's a little bit too thick. So what I'm going to do is make it still very thick. Apply again. Now it looks much better. So I use this one to bring to the center. Okay. And now you can see that we have, a 3D tube that both come from the streamer. And we can turn on the glyph again, so you can show both. So that's an example to show how to use to show both scalar and vector attributes of our data set. Okay, I'm going to load in another data set. And one way to clean up reset the current session is click Edit and the Reset Session. It's all gone refresh to the beginning. Now we can load another data set. I'm going to load a medical imaging here. It's a CT scan. By default, you see it shows offline. I'm going to show it as a volume. You see, the nice part is, you see, it's a human's head. It's CT images stacked one over the other to form a 3D images. and we also call it a 3D volume. And for this volume, we can visualize in each way, and we can change the opacity to make the lower part more transparent. You can see the skin part and the skeleton part. So that's some way to visualize this one. Another way is to extract the isosurface of this data set. So basically, you click on this one, contour, click apply. I turn off the original one, so I only show the contouring, which also called the isosurface. So basically, isosurface is a surface of a constant value that you give. So here I give 2047, and that value pretty much define the bones density in CT. But if I change that one, for example, I change that one to 800, it pretty much defines the skin part. So you can see the human skin is showed up. So it's all up to you to define which part you are going to show. And here is some example. And I'm going to show how to do the animation now. So basically, you click View and check the animation view. You can see the animation view is showed up in the bottom, just below the render window. Okay, so basically, there's a bunch of ways to animate. Click the animation subject. For example, I'm going to click on the camera. I'm going to orbit around, so I click the plus sign to edit that one. I say OK. So let's give it a look. So on the top, you just click the play button. A little bit too fast. So I add, instead of 10 frames, I make the 100 frames. And let's play again. Okay, that's a kind of animation. Now I'm going to add another one. I'm going to play on the contour. Okay, on the contour, I'm going to play on the isosurface. So basically, I'm going to give different ISO value because the isosurface is defined by ISO value. So the smaller it is, probably is only show the surface of the face of the person. But if it get when the value get higher, it shows the bone structures. So let's see the animation on that. So I click on that. It's added here. So I can edit this one. So basically, I say OK. So let's play it again. Now you see from the face, you see the bone structure as the surface as the ISO value goes up. Then you see the highest density as our teeth. Okay, it's very interesting to know that. And if you don't want the camera, you just make it disable it. You play again. Now this time it won't rotate. Just from specific viewing angle to see the changes of isosurface. All right. Now I'm going to. We have 15 minutes. So let's go to the next topic, how to load your own data into ParaView. Okay, so before doing that, I'm just reset this session. Okay, So I'm going to this part. Okay. So imagine I'm going to I'm doing a simulation, and I'm going to generate a data set at each time step, and each time step. But now don't consider the dynamic part of the animation. I focus only on one time step. So how to generate one data set, which is very simple. It's a uniform grid, and it's 3D, and it's only contain one scalar. The physical meaning of the scalar here, I don't care. You can consider it as a density or temperature, whatever. So let me show you how to do that. So sorry, around. Okay, probably I make it larger. Okay, so now I'm going to create a 41 by 41 by 41 a data array and write that one into a data file. So basically, you can see I have 3 nested for loops, and it's a loop. Each loop is from -n to n. N is 20, so that means from -20 to 20. So for each dimension, I have 41, and the second dimension 41 2. The third dimension is 41 2. And I have a big array that I previously allocated. So it's a dim is 41. You see dims here defined by 2 times n plus 1. So I create this big array called A, and I fill it up. I comment up these 2 lines. I use this line. So this line, if you make a focus, it's just a sign statement. So this is the thing that I align to the left, and this is I use some fancy functions make the result a little fancier as a function of I, j, and k. But if you want to feel whatever value that you think it would be interesting, you can put it there. And after I generate this big array called A, I simply open a file and I write it out. Okay, write the big array A into that file, and then all done, finished. So free A and close the file. That's all. Just that simple. So I don't have time to run, but trust me, this file is what I get if I run this. If I compile and run this file. So let's load it in. Because this is a raw file, I select it, click OK. It will ask me what it is, because it doesn't recognize. If we recognize, it will load it right away. Because it doesn't recognize, I say, okay, it's binary, not a raw file. It's raw binary file. And then it will ask me, okay, what it is. I need to specify, okay, because I use a float, not an unsigned character. It's a little ending. 3-dimensional, blah, blah, blah. The date extension is from 0 to 40. And 0 to 40, so it's the span is 41. 0 to 40. After that, I click Apply. So I got my display here. Okay, so that's the default display, which is offline. If I use Surface, and I can choose instead of solid color, I choose my property, something like this. Okay. And if I use volume rendering, because this is quite volume rendering, I can use this one. You see, I can change the color mapping, the transfer function on right, change the appearance. So something like those. So it's pretty good. So that means I can load my data into ParaView. But this looks kind of odd because every time you need to specify the type of the data, is whether the big ending, a little ending, and specify the dimensionalities. And how can we avoid this? One way is we write the data into a format that ParaView support. Okay, to do that is one format is popular. It's called NetCDF. Okay, so it's very simple, actually, not very complicated. But you need to link this with the NetCDF library. So on Sharcnet, you need to load it in this way. You use module load NetCDF. I use Intel version, and then you compile it. But make sure that you specify your link with CDF library. So that's all. So the source code part is, if you look at the source code part, it's pretty much like the previous one, like the raw file writer. The first part is identical, but if I just fill up the big array called A, okay, and then only the different part is the following part. So now I create a NetCDF file handle in this way, and then I specify what's the dimension on X, Y, and Z, and then I write the data set. Or I specify the data type is float. I give it a name called density, and that's all. So that's all done. Then I just use this statement to write it in. Those are the functions of NetCDF. You can look up the NetCDF tutorial or documentation for those for a complete function or the interface that you can use. Okay. So assume I do it and I compile it and I run it, and I got another one called E. The NC is a reserved data format for extension name for NetCDF. So let's load that in. I turn off the one, and I'm going to load this one. Click OK. So it asks me what type of NetCDF. I say it is the generic one, NetCDF. So OK. Apply. I don't need to twist anything. It is exactly the same thing if we switch to, it's now I show the one that I write as NetCDF. So it's loaded in just like this. All right.